Hi everyone. So welcome back to the channel. And today I have brought a topic, metrics. Okay, I know that I have not covered this topic like yet. So yes, today I'm going to cover the same topic because metrics is one of my favorite topics among all the topics that I have mentioned earlier. So yes, today I'm going to start with the metrics, and this is the first time I'll be talking on metrics. So today's video is going to be on the basics of metrics. Okay, I'll just explain you the basics of metrics, where I'll take maybe few examples also just to make you understand, and then I'll make a separate video of metrics where I'll be solving a lot of questions on metrics. Okay, because practice is the only thing which will make you perfect. So yes, I'll be focusing on the practice part as well, but that I'll be doing in the next video. In today's video, it is all about the basics of metrics. So I just want you to watch the entire video, okay? So please be with me till the end, because today I am basically going to write down on something new, okay? So for that, let me share what I have brought for you. And you can see that I have brought a different OneNote. So this is a OneNote for Windows 10. So I downloaded it. I was like, no, I have to make it here because I can see that I'm having a lot of options here of using a color pen and a lot of more things. Okay. So yes, today's topic is metrics, as I said. So let me write down the topic only. So yes, as you can see, the color is quite interesting. So yeah, so today's topic is metrics. So as I said, I'll be just covering the basics of metrics here, okay? Now the first question is this only, that what is metrics? What is metrics? It is a very straightforward and simple. The definition is very straightforward and simple. It is nothing but it is like a rectangular arrangement of numbers. That's it. Okay. So we just need to arrange the numbers in rows and columns. That is called matrix. Now, one more thing you should be aware of, that I'm not writing all these things because I hope you are listening to me. If you think that you are keep on forgetting, you can just go back to the video, you can pause it, you can write down the definition also, what I'm saying. So yes, matrix is nothing but it is the arrangement of the numbers in a rectangular box in rows and columns. That's it. Now, one thing that you should be aware of, that we always write down the matrix inside this bracket, which you can see here. So yes, this is the bracket we use to write down the matrix. For example, we have a matrix of certain rows and columns. So we always denote it with a capital letter. So A equals, and then you will denote it like this. Okay. Now, one more thing about matrix, that what is the order of a matrix? Okay, before writing the order of a matrix, let me tell you that whatever entries we are going to write down inside the matrix, those entries are called, okay, those entries are called elements. Each entries, okay, so each entries are called elements, okay. These are some basic things I'm telling you here, so please make a note of this, okay. Now, as I said, the order of a matrix. So what is the order of a matrix? First, let me tell you where do we write down the order of a matrix. We write down the order of a matrix right here, okay. So do you know that we write down the order of a matrix like this: m cross n? We read it like this: m cross n. Now, what is this m and what is this n? Let me tell you. So here this m is, okay, let me just decrease the length. Yes. So m is here the number of rows. And n here is the number of columns. It's as simple as that. M is the number of rows and n is the number of columns. So here, whenever we write down the matrix, we write it like the matrix inside this bracket, which you can see, and with the order. Don't forget to write down the order, okay? So order is very important. For example, because I have already said that what is matrix, it's just the arrangement of the numbers inside this rectangular bracket. So let us take one example. For example, I have The entry is like 1, 2, 3, 4. I have just chosen it randomly. Now the question is, as I said, we always write down the matrix with order. So how we can write down the order? The order is m cross n. That means we always write down the number of rows first, and then we write down the number of columns. So number of rows, I hope you can count the number of rows here. This is the first row and this is the second row. So what is the value of m here? That means the number of rows. The number of rows is 2. So you write down m equals 2. Now, what is n? As I already said, n is the number of columns. Number of columns is you will write, basically count like this, number 1 and number 2. If you are confused, I can just tell you this is row 1, this is row 2, that is why m is 2. This is C1 because column. So I'm just writing C and C2. So how many columns are there? 2. So this is 2 cross 2. Now this was very simple because we could see that number of rows was also 2 and number of columns was also 2. So yes, it was just a matrix with 2 cross 2 order. Okay, this is the order of a matrix. Of course, I'm going to take some more examples of order also, but later on. Okay, let us now proceed to the next topic. Now we will understand a lot of types of matrix. Okay, so now the next thing that you're going to study is the types of matrix. We will be studying a lots of matrix. Okay, so make sure you are watching this video carefully so that you will never get confused. Okay, so yes, this is the types of matrix. And what is the first matrix that I'm going to talk on? The first matrix is row matrix. This is our first matrix. Now, what is row matrix? If I just tell you the definition of a row matrix, so a row matrix is a matrix which has only one row. And how many columns? It can have any number of columns. All right. So what is a row matrix? Row matrix is a matrix in which we have only one row and column. Number of columns can be of any length. It can be 1, it can be 2, 3, 4, 5, 6. It can be n. Okay. So that is what row matrix looks like. Now, if I give you an example, okay, give me a moment. So I'll just write down. I'll just take this color and yes, I'll write down the definition. So row matrix is what? In short, I'm writing. So it has only one row and how many columns? N columns. Here n is just telling you that n can be anything. N can be 1 also, 2 also, 3 also, 4 also, 5, 10, 100, 10,000, anything. Okay. So yes, this is one row and n columns. For example, suppose I'm having a matrix A. So it will look like this: 1, 2, 3, 4, 5. For example, how many rows can you see in this? Only one row, right? Because you can see that this is indicating the rows. So this is row 1. So only one row. So you will write on 1. Cross. How many columns are there? You can see 1, 2, 3, 4, 5 columns are there. So the order is 1 cross 5. Now, in general, how do we write down the order of a row matrix? So it is something like this: a matrix A, and then of course the sign, this bracket, and then 1, because the number of row is going to be 1 always. So 1 cross n. This is how we write down the row matrix. I hope it's clear. And now let's move to our next matrix, which is of course column matrix. Now, many of you already know now that what can be the definition of a column matrix. So yes, let's write down for column matrix. So column matrix is nothing but one column and infinitely many rows. Okay, so infinitely many, that means it can be anything. So for column matrix, the matrix which has only one column, but the number of rows can be anything. Okay, so yes, we can write on one column. And then how many rows? M rows. I'm just writing M because I was earlier, when I was writing the order of a matrix, I was using the terms M and N. So yes, one column and M rows. Okay. So for example, here it can be like this: A equals 1, 2, 3. Okay, so how many columns are there? Only one column. So yes, this is going to be a column matrix. So only one column. How many rows? First row, second row, third row. So how many rows are there? 3 rows are there. And how many columns? 1. And remember that in general, we can write down the order of a column matrix as M cross N. Unlike this, here it was 1 cross N, here it is M cross 1. So remember this column matrix and row matrix. Now let's come to the next matrix. The next matrix is a square matrix. Okay, very interesting matrix. Square matrix. What is a square matrix? A square matrix is basically a matrix where the number of rows equals number of columns. That's it. So I can just write down the definition directly that in square matrix, number of rows is always equal to number of columns. That's it. So that means, in other words, we can also say M is always equal to N. Now, if I say that, can you give me an example of a square matrix? So, like, you just give me any example where M is always equal to N. Okay. So, for example, I can just give you A equals, I had already given you this example, 1, 2, 3, 4. Okay. So if you're getting confused at why I'm always writing the numbers, I can just do something for you. I can write down anything here. Okay. I'm writing A, B, C, and D. How many rows are there? Absolutely 2. So 2. How many columns are there? Absolutely again 2. So cross 2. Can you see that this is M and this is N? Are we here having M equals N? Yes, we are having M equals N. And if that is the condition, then such matrices are called square matrix. Remember, I'm using sometimes the word matrix, sometimes the matrices. Matrix is a singular word and matrices is plural. So I hope there is no confusion here. Okay, now let's talk about diagonal matrix. Okay, what is a diagonal matrix? So diagonal matrix is very simple. Okay, let me write down first what is a diagonal matrix. Let me tell you the definition of a diagonal matrix. Now, first of all, you should be always aware that diagonal matrix is such a matrix which is basically, it is a square matrix. Okay, in diagonal matrix, the very first condition that you should be aware is that the number of rows will always be equal to the number of columns. Okay, always. This is something that you should know. Now, what is a diagonal matrix? So we can also define diagonal matrix as a square matrix is said to be a diagonal matrix. Instead of saying a matrix is said to be a diagonal matrix, you can just rephrase your definition by saying a square matrix is said to be a diagonal matrix if all the diagonal entries, if all the diagonal entries are 0. Okay, if all the diagonal entries are 0, that is a square matrix. Okay, so let me tell you what is the example of a diagonal matrix. For example, we can also call it like this. For example, A is equal to a matrix A, B, C, and D. Okay, so clearly you can see here that this is a square matrix because it is a 2 by 2 matrix. So it is a square one. Now, do you know that the definition of a diagonal matrix, we also write down like this, that A is equal to Aij. I'm just writing the general form. Here I is the number of rows and J is the number of columns. So this is basically a diagonal matrix only if Aij, okay, for all Aij equals, or we can say Aij equals 0 for all I not equal to j. Okay, this is the definition of a diagonal matrix. So here, what does I not equal to j means? I not equal to j means is that it is it is not like, see, when I'm writing A11, that means I is equal to J. That means this can be anything, okay? This can be anything. It can be a 0, it can be a non-zero number. But if I'm writing A12, that means I is 1 and J is 2. That has to be 0. Okay, I think I said some opposite thing initially. I said that all the diagonal entries are 0. No, all the non-diagonal entries, or we can say off diagonal entries, should be 0. Talking about diagonal, it can be anything. Okay, so for example, I can just make you understand like this, that I'm having A is equal to, I'm just taking a bigger matrix this time just to clear any doubt. For example, this is, I'm writing A11, A12, A13. Do you know that we write down the entries like this only? A11 is denoting the first entry, first column, first row and first column. A12 is first row, second column. A13, first row, third column. Because you know that this 1 is indicating the number of rows. The second number is representing the number of columns. Now the second one, this is, of course, we are talking about the second column, first entry. So A21, A22, A23. Why this is 222? Because we are in the second row. That is why. Now I'm going to the third row. So A3. Why 1? Because I'm in the third row and the first column. That is why it is A31. This is A32 and this is A33. Now you can see the definition says that it is a diagonal matrix when Aij equals 0 for all. This is a sign of for all, if someone is not aware. For all. Now, I is not equal to j. When is the case that when I is not equal to j? This is the case. 1 is not equal to 2, of course. That means I is not equal to j. This is the case. This is the case. This is the case. This is also, and this is also. So, do you know that these are also called non-diagonal entries? And something which you can see here, okay, this is called diagonal entries. Okay, this is called diagonal entries, and if I just go this way, these are called off diagonal entries. Or if I just remove that, okay, so, then all the circle things are, we can also call it as a non-diagonal entry. Okay, so all these non-diagonal entries have to be 0. Then only we can say that it is a diagonal matrix. Okay, so for example, I can give you A equals, it can be anything, as I said, 1, 2, it can be 0 also. That is why I'm just putting any one value to be 0. If you just want, you can just put this as 0, but I'm just writing this as some of the numbers as non-zero. So you will understand the definition of a 0 matrix as well. Okay, so this is 0, 0, 0, 0, 0, and 0. If any of the non-diagonal entries, a single one also, is non-zero, it will not be a diagonal matrix. Okay, I hope you understood the meaning of diagonal matrix, and I hope you understood the meaning of diagonal elements also. What are the diagonal elements here? A11, A22, A33. Just for your information, I'm going to write down this as well. A11, A22, A33 are the diagonal elements. Diagonal elements. So if you're getting confused with the things that I have written, Aij is equal to 0 for all I not equal to j, you can also call it like this. All the non-diagonal elements, which are A12, A13, A21, A23, A31, A32, that has to be 0 only. Okay. So I'm just writing one more thing here, that here this ij, do not get confused. This I is the denoting the ith element in the row. Okay, ith element in the row, and the j is nothing but the jth element. This is in the row, and j is the jth entry or jth element. I'm just writing both the things, element or entry, jth element in the column. Okay, so yeah, That is the definition of diagonal elements, diagonal and diagonal matrix also. Now let's talk about our next matrix, which is a scalar matrix. Okay, let me write down the name first. I'm using a lot of colorful pens now. Let me use this. Now the next is scalar matrix. Okay. If you think that you know the answer of a scalar matrix and you want to just cross check your knowledge, whether you have remembered this scalar matrix or not, you can just pause this video right now and you can, read your definition, or you can just recall what you have learned and then match with my answer. Okay. So let me tell you what is a scalar matrix. A square matrix. Again, I am saying scalar matrix as a square matrix because all the scalar matrix are square matrix. Okay, so we can also call it like this. A square matrix A equals Aij is called a scalar matrix if all the of course non-entries, non-diagonal elements are 0 and all the diagonal entries are same. That is the meaning of a scalar matrix. In other words, we can also call it like this. The scalar matrix is nothing but it is a diagonal matrix. Along with that, all the diagonal entries are equal, or we can say are all same. For example, as I said, it is a diagonal matrix, and you know already what is a diagonal matrix. Along with that, there is one more condition for scalar matrix, that all the diagonal entries should be same. Okay, all the diagonal entries or diagonal elements, you can say, diagonal entries or elements should be same. That is the meaning of scalar matrix. All right. So yes, we are done with this. Let me give you an example quickly. So the example is I'm writing A equals, of course, it has to be a diagonal matrix first. That means all the non-diagonal entries should be 0 and all the diagonal entries should be same. So I'm just writing a general formula. For example, I'm writing K here, then this has to be K, this has to be K also for this matrix to be a scalar one, and these all should be 0, 0, 0. Okay, so this is the general form. If you want, I can also give you an example. For example, A equals K can be anything, but it should be same. So for example, I'm saying K equals 5. So 5, 5, 5. If it is 1, then 1, 1, 1. If it is 100, 100, 100, 100. I hope it's clear. And then the rest will be, of course, 0. So this is the definition of a scalar matrix. Okay. I hope you are understanding all the videos which I am explaining here, all the topics which I'm explaining here. If there is any doubt which you are not understanding or anything, please let me know about it in the comment box. Okay, let's now move to the next topic, which is null matrix. Okay, so now we will be doing our next matrix, which is null matrix. I hope it's like very clear with the word only. Null matrix is a matrix in which all the entries are 0. That is it. All entries are 0. Be it be it 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix, any matrix. Okay, if all the entries are 0, it will be a null matrix. So all the entries are 0. For example, I'm giving you a very simple example, 0, 0, 0. Even if I write down a matrix of higher order, it is going to be 0, 0, 0, 0, 0, 0, 0, 0, 0, and 0 only. Okay, so that is the meaning of null matrix. Now let me talk about two most important matrices, which is upper triangular matrix and lower triangular matrix. So this is upper triangular matrix. Can you notice here one thing? That upper triangular, that means we should see an upper triangle somewhere, right? So upper triangular matrix, I'll just make you understand with an example, because with the example it is very, very simple to understand. So for example, I'm having a matrix of order 3 by 3. Okay, let me write down the diagonal first. Okay, so for example, I'm writing 1 2 3. It can be anything. Okay, it is not like it is not fixed that it should be a 0 or non-zero only. It can be anything. Now, the one thing that you should remember is that it is forming an upper triangle, right? So here imagine I'm putting 4, here 0, here 5 or 0, anything. Can you see that if I draw something like this, am I getting an upper triangle? Yes, I am getting an upper triangle. And once I'm getting an upper triangle, all the rest entries they have to be 0, right? So except 0, you can see that we are forming an upper triangle. So yes, that is a very simple and very straightforward definition of upper triangular matrix. Okay, so let me just show you that yes, this is our upper triangle. Now, as soon as I explained you this upper triangle, it is very simple for you to understand lower triangular matrix. Just make sure that the entries which are outside the triangle has to be 0 only. Okay, so now understand lower triangular matrix. Now, lower triangular matrix, let us take now B. Okay, I was taking A for so long now. So B equals, this is of course the way we represent matrix. So now let me write down the entry. For example, I'm writing 0, 5, 10. And then I'm just writing here 6, maybe here 0, maybe here 5. Okay, and now you can see that if I just see this part, it is forming an upper triangular matrix. If you can notice, yes, upper triangular matrix. And except this, all the other entries have to be 0. So 0, 0, 0. That is it. This is the definition of upper triangular matrix and lower triangular matrix. Okay, I hope you understood this. Now let us understand something more about when two matrices are equal. Okay, we will understand few more types as well. Let us, like, whatever I'm getting in my mind, I'm just writing that. So when two matrices are said to be equal. So let me tell you, there are only two conditions for two matrices to be equal. First of all, their order should be same. It is not like one is 2 by 2 and the other is 3 by 3. No, absolutely not. The very first condition is that it has to be of same order. And the second condition is that the corresponding entries should also be same. Okay. So the first condition is it should be of the same order. It should be of the same order. And the second condition is that the corresponding entries, okay, the corresponding entries should be equal. The corresponding entries should be equal. I'm not taking the example here because, as I said, I'll be making another video in which I'm going to cover as many questions as possible, where I'll be covering all these topics as well. Okay, where the two matrices are equal, for what value the two matrices will be equal, all those questions I'm going to take. Okay. Yes, so now we have covered this also. Now we have some more metrics as well. We have some multiplication. How do we do the multiplication of a matrix as well? And multiplication of a matrix, I'm going to explain you in the in the practice video itself, which I'm going to make next. So I'm not explaining you how to do the matrix multiplication, of course, because you will be understanding that later on. Now, one more thing which I remember, that you should know what is transpose of a matrix. Okay, what is transpose of a matrix? Let me first tell you that how do we denote transpose. Okay, so for that, let me tell you. So for example, if I'm taking a matrix A, then transpose of a matrix is denoted by just a letter T on the top of A. Okay, on the power of it. Now, what is the meaning of transpose of a matrix? For example, I'm having A is equal to 1, 2, 3, and 4, 5, 6. Can anyone just pause this video and tell me what is the order of this matrix? So please pause it and check whether your answer is correct or not. So the order is, how many rows can you see here? 2 rows, row 1 and row 2. So 2 you will write down. How many columns can you see? 1, 2 and 3 columns. So 2 cross 3. This is the order of a matrix here. Okay. So we revised order of a matrix as well. Now we are understanding what is a transpose of a matrix. So this was our initial matrix. Now we have to do the transpose of a matrix. Do you know that the transpose of a matrix is just number of rows will become the number of columns and number of columns will become the number of rows. So as you can see, what is the first row here? First row is having 1, 2 and 3. First row will become first column. That's it. So what is it? This will become 1, 2, 3. What is the second row? Second row is 4, 5, 6. Second row will become second column. So this will become 4, 5, 6. So this is the transpose of a matrix. Now let me tell you a very interesting property of a transpose matrix. That if I take the transpose of a matrix and I do the transpose of that transpose matrix again, it will be the initial matrix only. You will get back your the previous matrix only. For example, you can see that I got a transpose matrix here. Now I'm going to do the transpose of this transposed matrix. So what I'm going to do, A transpose raised to transpose. That means I'm writing the transpose matrix here, which is 1, 4, 2, 5, 3, 6. I have to do the transpose of this again. Okay. So what this will become? You know that the number of rows will become the number of columns, or you can say the number of columns will become the number of rows. So what is the first row here? 1, 4. First row will become first column. So 1, 4. Second row will become second column. So 2, 5. Third row will become third column. So 3, 6. Can you notice that this is nothing but A? Our previous matrix. So this is a very, very, very important property of a transpose matrix, that if you do the transpose of a transpose matrix, you will get your previous, the initial matrix again. Okay. Now, as I said, I'm not going to talk on the matrix multiplication because I'll be explaining that part in the practice video itself, which I'm going to upload it by maybe tomorrow or day after tomorrow. So you don't have to wait for long. If you are watching my videos with that much interest, then only. So yes, I'm going to talk about matrix multiplication in the next video, where I'll be solving a lot of questions on matrix. Along with that, I will also tell you some important properties of multiplication in matrix. Okay, so that I'm also going to cover in the next video only. Now, I think I have not left any other thing. If I have left any other thing, I'm going to cover it in the next video for sure. And on that note, I remembered one more matrix, not one, two more matrix. Okay. So yes, two more matrix I'm going to cover here only, and that is symmetric matrix and skew symmetric matrix. A very important question comes in the board exam. Always I have noticed it. that of course I'm going to cover in the next video. I'll just tell you the meaning of symmetric matrix and skew symmetric matrix. Okay, very simple. Of course, I'm going to take example of this symmetric matrix and skew symmetric matrix in the next video. I'm going to just tell you what is the meaning of symmetric matrix. So symmetric matrix is nothing but if you have a matrix, if you do the transpose of a matrix and you get back the initial matrix, then the matrix is said to be a skew symmetric matrix. Very simple. Suppose you have a matrix, you are taking the transpose of it and you are getting back the same matrix, then it is called a symmetric matrix. Yes, it is possible that you are taking a transpose, but you are still getting the same matrix. That you will see in the next video. Okay. Now talking about skew symmetric matrix, very simple. It is almost like a symmetric matrix with a negative sign. That's it. For example, you have a matrix, you are doing the transpose of it, and you are getting the negative of that matrix. Such matrices are called skew symmetric matrices. So I hope I have covered almost all types of matrices in this video. And if you have basically liked my videos, then please subscribe to the channel. I need your support, I need your love, and I'm getting it. I'm fortunate, I'm grateful for you guys. Thank you so much for supporting my channel. Thank you so much for subscribing to my channel. Thank you so much for all my current subscribers. I need more subscribers, of course. And then of course I'll be making a lot of videos for you guys. Thank you so much for being just consistent to my channel. So see you soon in the next video. I'll be making basically matrices, solved matrices questions. So that will come super soon. Thank you so much for being here, for being watching my channel, and just thank you so much. Yes.